Welcome, welcome to Tampere, Finland. We are here next to the University of Tampere, but we are not at the university. We are at the office of the company called Stora Enso. And we are going to speak today about some technology that could be interesting for you as a students and could be interesting for you as a developers. Uh, I will introduce myself a little bit later, but I can tell that my role here is to be the solution architect. So, FeathersJS, real-time API via Socket.io. If you haven't learned about Socket.io before, this is something that would help you to organize the real-time communication between your server side and the client side. And it would help you to speed up the traffic between those. But today on this lecture, we are going to cover those, wrapped up into Feathers.js. So what would be the main topics of this lecture? First of all, I have to say thank you for the chance that I can share this knowledge for you. And I would like to say thank you for you to watching this, so we all can speak together about the newest, maybe not so newest, but still interesting technologies. FeathersJS is the real-time API, real-time communication API, which supports two protocols, HTTP as a RESTful API and Socket.io via the messaging through or via WebSockets. Also, you can establish the user authorization layers. We will cover a little bit about when to use HTTP and when to use Socket.io, and at the end of the lecture we would cover a little bit about the MQTT, which is also the protocol for messaging message exchange. We will cover how to implement the server side using features. We will receive data from the clients. We will forward the data back to the clients, and we will forward the data to the web dashboard, web UI in real time. So all the data will be updated in real time. The client implementation is in React. It receives the data from the server side when devices are reporting, and it also builds up the charts in real time. When the data comes, it builds up the chart so you can see how your devices are behaving. And at the end of the lecture, we would cover a little bit how do you deploy the solution with horizontal scaling up and then the messaging backplanes. It's really important to understand when it comes to the end. Every project eventually comes to the end when it needs to be presented to customers and it needs to be presented to real world, how to deploy, how to make sure that all the data is coming to the right places. So who am I and why am I talking to you today? My name is Sergey Sedelnikov, and my role at Stora Enso is the solution architect and being a project manager. For the last 2 years, I got my education in Russia. Back in 2003, I got the master's degree in mathematics and simulation of control processes. So being at this big company like Stora Enso is actually my main domain of the knowledge. You can read about rest of my career in this slide, but I don't want to spend a lot of time on my personality. What is Stora Enso? A few words about the company. If you didn't know that, we are not the consultant house. We are not the IT company in the pure meaning of this word. We are developing we are making the paper, the wood products, the packaging, and the biomaterials like pulp and wood chips and all the corresponding goods. So the Stora Enso is the classical company from this point of view. And you may ask how can we and how do we relate it? How are we related to IT? And because of Stora Enso is a company which has a lot of equipment in use, RFID readers, smart cabinets, RFID tags. We need to know about IT, and we need to know about latest technologies quite a lot to be kind of a, not to be in a tail of the big companies. So we want to be quite modern and use the cool things in our work. In global scale, we have 27,000 employees, but of course, most of them, they are working in the mills, which are producing the real goods. And we have also the R&D offices around the world. And here at Tampere, we have so-called Tech Performance Center, Intelligent Packaging Division, with around 30 employees. And our main focus of work is the logistics, track and trace, and the smart vending machines, smart supply through RFID technology. If you don't know what is RFID, it's the radio frequency identifier. You can see it on the picture. It's a special kind of tag which can be read from the distance with the equipment, like you see on the right side of the picture, on the right side of the slide. So back to technology. Why do we need to use this real-time communication, and why it's so important, and what we are going to achieve by the end of this lecture? And if I tell you that the lecture would last about 1 hour, we will cover the source code. We will run the demo application that you see on the screenshot on the left, on the right. Sorry. So we have a lot of machines at the company, paper machines, different kind of equipment that always runs 24/7, and we would like to know how it runs. Does it running well or not? So by this demo that we are going to cover today, I try to simulate several motors that runs on a certain revolutions. We have the gateway, which kind of translates the data from the motor to Feathers API server through Socketlo. And then we have the web UI, which shows the motor, the speed of every engine that we are running. And as an administrator, you can control, increase the speed, decrease the speed, or stop the motor. Of course, this is all pure simulation. There is no real motors in this demo. But you can imagine that we have these giant paper machines that runs 24/7, and probably nobody wants to get them stuck by some point. So this is the perfect case how the real-time API and real-time communication helps to digitalize the business in this kind of a big words of it. Here is the example of the paper machine, how it looks like. So it's about 100 or even 200 meters long line with many different rows, with many different motors and pumps. They pumping chemistry, they pumping the water, they heat up with the electricity the paper, they dry it up and roll it into in the giant rolls. So that's what I was talking about. And if you want to read more about Feathers, here is the website on the slide, and later I would of course show you the GitHub repository that I made that you can pull to your local computer and run it. You don't need to have paper machine for this exercise. What is Socketlo? I've been speaking about Socketlo for the last 10 minutes maybe, and if you think about in general what is Socketlo, it enables the real-time communication between your server and your client. So it creates the bidirectional channel between them. It opens up the channel. Once the channel is opened, it keeps it open until the client shuts it down or until the server shuts it down. The good example of how can you use Socketlo is the real-time messaging if you want to build up the chat. If you want to have online document editing, like in Google Docs or Microsoft Office online editing feature, you see who is editing documentation, and most probably it implemented with this technology or similar technology. it can be also done. It can be also used for file sharing, because streaming through Socket.io is much faster than with. I don't even know how can you do it in HTTP, but probably HTTP is also supports this binary data streaming, but it's not streaming. It's just downloading the data. But with Socket.io, you can stream and watch some videos. Let's say media streaming. Socket.io uses a web socket transport, but it is not a WebSocket implementation. It adds additional layer of responsibility on top of WebSocket. If you don't know what is WebSocket, unfortunately, this falls away from this lecture material. You need to learn about it yourself. But you can think about WebSocket as the TCP socket, but for web. That's actually kind of a easiest explanation for this. So FeathersJS architecture. So FeathersJS is the special framework that was written by third-party people, not by us, but somebody made it. And how it works is it supports, it's so-called transport agnostic API. It supports both transports, HTTP and Socket.io. So by first of all, you are making APIs with this. Usually it's a so-called CRUD APIs, create, update, remove, create, update, read, and delete, CRUD. You making this post, you making this get, post, put, delete request to it like normally. But at the same time, you can do the same through Socket.io transport. And you see on the picture I put here so-called a chain of middlewares. When the signal comes to the API, it goes first to authorization middleware, then it goes to so-called before hooks middleware. Then it executes the method that you written in Node.js. And again, I forgot to tell you that all of this code is written in Node.js, and it should be deployed to the server that supports Node.js deployment. After before hooks executed, the service method is executed, and then when the service method is executed with success, it starts executing after hooks. And maybe you can be a little bit confused now. What are those before hooks and after hooks? This is special FeathersJS mechanism to that allows you to execute additional shareable logic before the main method executed and after the main method is executed. The good example for this is if you want to save some audit message that, let's say, as an administrator, I want to stop the motor. And in before hook, you could save the additional message to the database that administrator with this ID stop this motor at this time. Then you call the method that stop the motor. And then after all, you maybe want to send some notification somebody that motor was stopped, email. That can be done in after hooks. So and these hooks can be shared between methods. So all the methods can have this audit message saving, and some of the methods can have the after hook to send some notification to somebody, some email or SMS. Better to do it and wrap it up into hooks. And now the magic is coming. Have you ever thought about that you want to get a real-time notification on somebody executing something? Let's say I'm the operator of the machine. I'm stopping the motor, and I want that the dashboard that shows me the motor status would show the changing status immediately after the motor has been stopped. And FeathersJS implements so-called notification layer. When somebody executes any method through HTTP, through WebSocket.io, is if anyone calling post or put or delete, so something that changes something, FeathersJS generates so-called notification. And as a client, as a let's say web client, it can subscribe for those notifications. Let's say the code looks like client.on something created, execute this method. So you can update the user interface. And that's the most powerful thing in the FeathersJS. So it can notify you, not only you, but whoever is connected to API. Whoever is connected can be notified through the built-in mechanism that something has happened in API, and you can update or perform set of client-side activities on this. I will show you everything on the demo. I tried to make the demo covering most of the features, but of course not all. And I would strongly recommend you to take a look at the FeathersJS just because of this one feature, which actually speeds up a lot the real-time development. And we are using this FeathersJS in production in one of the biggest projects at our Tampere division. So that was a little bit of theory, and now we need to move from the theory to GitHub, open up the Visual Studio Code, open up the demo application. I will show it to you, and you will see how it works. And I will try to explain as clear as possible what is happening there. Of course, we're not going to write down the code from scratch. I will just clone the repository I prepared. And here's the link on the screen. You can also take a look at this yourself, pull it, change it, maybe even contact me if you have some improvements about it. And again, the backend side is written with Node.js using FeathersJS as the framework for API. The device gateway is a pure Node.js without any frameworks. It's really simple device gateway that connects to server and send the messages about the motor speed. And the client side is a pure React application without anything on top of it. Only, of course, the charts to show the charts. I mean, the charts module to show the charts, and some tweaks to a little bit throttle the events. But I will show you. Now it's time for switch to the code. So now we need to go through the demo, and I have here the Visual Studio Code, and I would also recommend you to try to open up the demo in Visual Studio Code. For me, it's the most convenient way of coding. As you can see, now we have the demo folder. Open it here, and this folder contains of three subfolders. First is the admin dashboard, the dashboard that we would see in the web browser. The second is the API server, the implementation of the server in FeathersJS and Socketlo, and the third one is the device gateway, a gateway that would send a motor speed to the server. Before hitting up the code, let's run everything and see what we are going to achieve. First of all, in the terminal, I would navigate. I first run the API. I want to navigate to the folder called API server, and normally, if you do it from scratch, you need to run npm install first, but I had it already here, so I will just call npm start, and it has this start script that starts the API. So you can see the console output here that it starts and everything seems to be okay, and now it listens the API on this port 3030. Let's check how it looks like on the browser. So if I navigate in the browser to this address, localhost 3030, I see the default page of Feathers and link to get more information about Feathers. So now let's open up a new terminal and do it so that I would navigate to admin to device gateway, device gateway folder. And what this project is all about is it just sends the data to the API. We will go through the source code in a minute, but what I want to do now is I want to run this but file. What it does is just runs index.js with node 4 times, and every time it applies the ID for each motor. Each motor has ID, which would be visible on the user interface, and each ID is basically the M, which stands for motor, and then the X, which is the loop variable. So if I now start for motors, but I hope it will work. Okay, so I would then just do it so that I would reveal it in Explorer. Maybe if I open it in terminal. No. Okay, I would then reveal it in Explorer. And I will just run it 4 times. So you cannot see it, but it would be the same if I would run it like this. So node index.js ID equals motor 1. Actually, let's start with the motor 1. Let's start it like this. So what you see now, it got connected. Let's stop it here a little bit. It got connected to the API on the localhost 3030. It got authenticated to API, and I implemented this fake authentication method there. And then it starts sending every 200 milliseconds. It starts sending it motor speed with the ID of the motor equals motor 1, and every time it sends something, it gets the speed. Let's now open up a new terminal and start the client, the user interface. I need to navigate to the folder called admin dashboard and call npm start. And this project is the pure React application. It starts the React script start, and it should take around 30-40 seconds for it to get started. Meanwhile, let's take a look at the source. There is nothing really critical or nothing really special is happening inside of the source. All what it does is just creates the application, and then it renders the navigation, which shows the logo, and then it starts it starts displaying for motors. And here you see that when the message comes, it contains the motor ID, motor speed, and update time. And for each motor in the list of motors, it actually displays the motor chart with the motor ID, speed, and time. And the motor chart collects last 100 events from the motor and display them in the chart. So let's now switch back to the browser, and I would show you how it looks like. Let me now open it up here. Yeah, now it loads up, and what you see now, we have a funny text called not authenticated, which means that we actually never been authenticated for API to fetch it. And do you remember in the slides I show you that Feathers is having this authentication layer. So basically here I implemented so-called GitHub authentication. And when you implement one of the standard FeathersJS authentication mechanisms, and the GitHub is the standard authentication mechanism, it generates you the a URL which is called auth GitHub. By navigating to this URL, it asks you to authenticate with your GitHub account. I do it with my. I hope. Okay. Oh, typo in the name. Yeah, never save it. So now we are authenticated. And actually what happened now is Feathers stores in the browser storage so-called authentication token. And it uses this authentication, the Feathers client, which is here, is trying to fetch same authentication token, and if it's valid, it can connect to the Feathers API. If I refresh the browser now, it will fetch this authentication token from the local storage of the browser, and it should start display as one chart, which is now one motor is broadcasting. Okay, so as you see now, we are getting one chart because we only have one motor acting, and on this chart you see it collects okay, I think it collects now last 50, not 100, but last 50 messages from the motor, and the motor is a little bit randomizing them so you can see the actual movement. And if I go back to Visual Studio, if I go back to here, not here, but here, this is the motor data that is now coming. I want to create one more motor. Oops, let me close this one. If I now navigate to device gateway, oops, typo, yeah, and if I type node index.js with the parameter id equals motor2, so now we have two motors reporting their state to the UI. Switching back to the browser would show us that we now have two charts, and all of these charts, they are displaying a motor speed. So let's take a look how this part was done, and let's then take a look at the next exercise would be how can we control the motor speed with the buttons on top, so we can stop each motor, increase the speed, decrease the speed, and so on, so on. So let's see how can we actually control. Let's see how it's done. I would now stop. I would first of all switch back to Visual Studio, and I would stop all the PowerPoint. Of course, not the PowerPoint, but I would stop all the browser thing and all the API and everything. Yes. Let me close the terminal. Let's start with the API. Quickly go through and then see how the other things are developed. So, first of all, when you are developing feathers, you don't need to rely on your own code. A lot of things been generated by feathers for you, and it's done because of this. Feathers has so-called CLI, command line interface, which called feathers, and if you install it through npm install, it allows you to generate new applications. It allows you to generate authentication layers like GitHub, Facebook, Google, and few others. It also allows you to generate hooks, services, plugins, and so on. So When you start with Feathers, I strongly recommend you to generate your code with Feathers CLI. The main code is here in source folder, and again, all of this code is automatically generated for you. What you need to focus on is on the hooks and on the services. And you see here in services, I created the new service, which is called motor speed. All the implementation of the service, your actual code, is in the motorspeed.class.js. And you see here I have only one method called update, and this update in HTTP REST API terms is put. Every time somebody called put, it actually updates the speed. And you see here what we are doing here, on what I do here, is actually nothing. It could be that on this point it could save data to database, it could save data to some other persistent storage, or it can send some email. But what we are doing here is we only concatenate the ID of the motor that the data was sent with and the actual data that came. It's a motor speed. And if you take a look at the device gateway code, because this is the code that calls this update method or put method, how it is done is actually here in motor.js class. What it does is every time we need to send a motor speed, it actually generates a new motor speed by randomizing the current motor speed plus minus some little deviation, and then it calls this onMotorSpeed reported method, and here in index.js on speed reported callback, it sends the data to API, and I made a class called reporter, and this reporter is connected to API and sends the data to the actual API. So it's kind of one of the object-oriented programming encapsulation. So I kind of close the what is actually happening in the reporter from the developer point of view. But in API reporter, when it calls the initialize method, when it starts, it connects to API via Socketlo, and this API URL is actually localhost 3030, which we are having here. What we do here when we need to send a speed value to API, we are having this application instance which we created in initialize, so it connects to Feathers via Socketlo, and it uses this API version 1 motor speed service, and then it calls update with this motor ID and the data. So every time we call update, it actually calls the API update through Socketlo, same as you would do it with HTTP. It's not really any difference, but it's just faster because we already got connection to Socketlo in the initialize method. And this code is really simple. It's basically copy-paste of the code from the Feathers tutorials. So every time motor reports its speed, it happens every 200 milliseconds, it just calls post API. So the question is how the user interface knows that the speed was updated. And you remember in the slides, I showed you this callback with the yellow line, that every time somebody calls post, put, delete, also patch, but it's not so commonly used. Every time somebody calls those methods, the Feathers generate so-called event that something was changed. Something was changed by calling this method, and anyone who is interested can subscribe for those. and our user interface is subscribing for this service dot on updated. Well, of course not this service, but this is already this code is already when user changes a speed. Now we are speaking about this. When I call this update, the user interface in the same time receives the message that this method was called. Let's take a look at the code. So I close this one. In admin dashboard, in application, when we create motors, each motor is having ID. The motor component, I mean, this is the visual component that React would render. The motor is created is ID and the current speed and the time when it was updated. And let me check the source code a little. Let me a little bit memorize my source code. Handle motor speed reported here. This method is happening every time we are something reported via the motor speed. Let me a little bit remember. I'm a little bit confused now where actually I am subscribed for these feathers. Here. Actually here I have this utilities folder which wraps up the all the code for the API connection. Here I am connecting to this URL on the user interface side. I am initializing the API connection, same way as I do it on the motor gateway, but nowadays instead of acting or executing the method, I am subscribing what would happen on motor speed updated, and this motor speed updated callback is executed every time the server receives the new value for each motor speed, and then it executes the callbacks if there is any callbacks that what to do when motor speed is updated. And here I have this on motor speed reported, and I am actually calling this method what to do. This method would be executed because I'm registered here as a callback. It's a little bit patterned here, so we collect all the callbacks, all the event handlers, and what this would be happening every time we are expecting the new motor value. And you see here I'm using throttle. So this method wouldn't be executed more than once per every 200 milliseconds. If I would be having 1000 motors, imagine if they would report me every 200 milliseconds each. So basically I need to update my UI every millisecond, even less, to kind of carry all these messages. So I'm throttling them with a low dash throttle method. And you can, if you doesn't know what is this, I would strongly recommend you to check this low dash library. It helps a lot to deal with the different kind of arrays, string methods, date and times, functions. And one of the functions is throttle. It actually limits the execution of this method only once per 200 milliseconds. And it allows the user interface to be updated less often. We're of course losing some data, but it doesn't really matter in this demo. It only gives the benefits of smoothing the UI updates. So what is happening on this handle motor speed reported method? Actually, it's here. It accepts the motor ID. What was the new motor? What was the motor which reported the speed? And in the React state, in the React application state, I am keeping the list of motors that were reported for me, and the list of motors is actually a collection of the array of motors. I have my C# slang here. The array of motors is the motor ID and the current speed, And when I get the motor ID, which I never saw before, it just pushes this to motors array. And if I get a motor which I already had before, I am deleting this motor by ID from the original arrays of motors, and I am adding the same motor with the current speed. So basically I'm replacing the object of the motor with the new speed. And then once this collection is changed, the render method hits up and it renders all of the motor charts on the screen. So the motor itself, it's actually a little bit more complicated thing to render the chart of the motors. It stores the last 50 motor speed values, and every time we got the new update, we are saving it to the list of saved values, so the chart can build last 50. And then we are updating the chart. Basically, this. Wait a second. Here, there is a line chart I draw using the last 50 values. Let's again do it so that I would start the API. What was that? Okay. API server and call npm start. Then I will start one motor. I'll go to gateway and start it, and I will do it so that node index.js id equals, let's say, motor 4. I just decided to be like this. Okay, now we get the motor reporting its speed, and let's then start the user interface. So I will demonstrate those control buttons for you and how they work. And I will do it so that I start admin dashboard, and I would call npm start. So it's really important to start first the API, so the device would be able to connect. It can handle the reconnections, the device gateway, but if the API is not initially running, it will fail to connect, and it wouldn't be able to it wouldn't be able to do anything with your thing. So let's wait a second until the development server starts, and I can then switch to the browser. Well, actually, I can switch to the browser right now. So what we did now is we went through the case when device reports to cloud or to API, and API reports to UI through the event callbacks. So the UI updates itself every time motor speed changes. Just not changes, but every time the motor speed reported. Now our goal is to demonstrate how can we control the motor from the UI. Okay, now I need to get again authenticated because actually it stores the token in memory, and because we restarted the server, token got voided, and we need to authenticate ourselves again. And because I already did enter the username and password to GitHub, it didn't ask me anymore. It uses the cookies. Now if I refresh the page, I should see our motor reporting the speed every 200 milliseconds, and it reports the speed up to the 50 values, and then it replaces them. But if I now want to decrease the speed by 20, I click this button, and you see the speed is decreasing. And what happened here is actually same thing, but the other way around. The user interface called the API set new speed for motor. And when this API is called, it basically generated the same message for the motor. And motor is having this subscription. So it will kind of understand that the signal came from API, and now I need to set a new motor speed. And if I want, I can drop it to 0, and then the motor would be stopped. Now motor is stopped, and it reports 0 speed every 200 milliseconds. If I want to increase it, I click to increase. The speed would be growing up to 10. If I want to increase it by 12, I will click it one more time, and the speed would be increased by 12. So let's see how this was implemented. Let me switch back to Visual Studio Code, and let's close. Okay, let's not close anything. So here we have these buttons on the user interface, and every button click is handle the motor speed change. And you can see if I navigate to this method, what it does is calculates the new speed based on the current speed of the motor, and called send motor speed method with the motor ID and the new speed. And if I take a look what is happening here in this method, you can see that I am actually executing the API service set speed update method with motor ID and the new speed. And looking at the API, if I take a look at API services, I have here set speed service, which actually again is having only one update method, which doesn't do anything. It just by Feathers engine itself, it broadcasts the message. Basically, after the executing of this method, Feathers broadcast the message that set speed service generated updated method, and whoever is listening for this updated method can execute something on this callback. So logically thinking that this updated method should be listened by a motor, a device gateway itself. So looking at the device gateway at the motor class, what we can see here is, let me check here. Yeah. Yes. Here, actually in the reporter class, when we subscribe for all the API events, if I take a look at the API reporter, I have here the method called here. This line of code is actually subscribe for callback from the API for API version 1 set speed, what to do on speed updated. If somebody sends this HTTP put or using the Socketlo client to set the motor speed, what it does is extract the motor ID and the speed from the payload, and it sends the callback on new speed command received. And here in the reporter it does nothing, but we actually override this method. If you take a look at the index, it actually overwritten. And if this motor ID equals the ID that was in the list in the message, because all the motors, they would receive this callback. And here's the actually filtering that only the motor which ID was in the payload need to set its own speed, and this motor sets its speed just by gradiently changing the speed until it reaches the target level. And you may ask here, why do I need to answer, why do all motors receive this message? Because they all subscribe for this Feathers callback. Is there a way how can we do that only the motor that we are changing would receive the the callback. Yes, it is possible to do it like this, but it's again a little bit complicated. You need to work with features channels. You can define its own channel for every motor, and you can basically, how they say it, subscribe for only the channel that motors are having. And by channel ID, I mean the motor ID can be a channel ID. But for now, we are not implementing this part, and what I did is I just have this line of code here, so that whenever we have 5 or 6 motors, they are receiving this message to set the new speed. I have here the check that if the message is for this exact motor, it should execute it. If not, then not. So that was the demo. You can download it, and let me check a little bit. Let me switch back to the browser so we can end the demo on the nice view. So that was the demo. You can download it and you can test it yourself. Using the Feathers CLI, you can generate your own endpoints, and you can actually enrich the endpoints. And you can always send me the message if something was not clear. And now we are going back to slides. Okay, so we went through the code. That was, I hope, not so difficult for you to understand. And you actually already noticed that in both of the clients, I mean the device client, which is the device gateway, and in user interface client, I only use socket IO access. I don't use HTTP. And there is a clear, how would I say, patterns and practices. How would you use, when do you use socket IO and when do you use HTTP? First of all of us know that HTTP is the request response. You make a request to server responds you with some data. This operation usually takes time. And when do you need to use HTTP instead of socket IO if Feather supports both? When you don't need to keep a connection all the time. Let's say the connection is poor, you don't want to keep it all the time up. You only want to report on demand. You wake up device once per half an hour, send the data, and then you shut down the layer, because usually keeping the connection up, especially if device runs on battery, is really power consuming operation. You need to be really careful about this. When you don't have enough bandwidth, when traffic is limited and you don't want to keep the connection open because you pay for every megabyte of data you're using. Let's say in case of satellite connection, it's really expensive, and because of socket IO sends ping pong messages every 20 seconds. It pings the server responds respond to keep the connection running. That's the point that it can generate you a lot of traffic. And then if you don't need to react on events, but only execute the CRUD operations, you don't have to have the socket IO client set up on your project. That's really simple. When you just need to call HTTP post, HTTP get, delete, or put, don't use socket IO. No need for this. But what happens when you need socket IO and when you need socket IO? On the picture, you see how clients communicates with the server with socket IO protocol, with socket IO framework through WebSocket protocol. It first initializes the connection with the server side. It grants the access. Then it establishes the bidirectional connection, persistent connection, so it never disappears. If the connection somehow dropped, the client tried to reconnect and then reconnect and then reconnect. And then when needed, one of the parties closes the channel. When you use this, you are using this when you need immediate notification on CRUD events. If somebody executed the CRUD events, not you, Of course, you know when you executed it, but if somebody executes it, you need to get a notification about it. That's when you get the Socket IO in place. When you have a stable connection, you also can use the Socket IO. And like here in Finland, most of the internet is unlimited. You don't have to pay for every megabyte of data. You are using the Socket IO in this sense. When you need a faster request response, because Socket IO is usually faster than HTTP, you already have a connection. You don't need to spend time on setting up connection. Like how HTTP works is first set up connection, get a handshake back, especially if it comes to HTTPS, where they need to exchange certificates and they need to check the certificates. It's usually 2 times more expensive in this sense of resources. And then I told already about this, but if you need to react on other clients' behavior, you need to get this Socket IO in place if you need to react on them executing something. What would happen if you would use 2 protocols at the same time? If you use both HTTP and Socket IO, this is completely possible. The Feathers is not really caring about what protocol you're using. You just need to use it somehow. Generally, Socket IO is faster, and if you have internet connection fast enough, or I would say good enough, you are better to use Socket IO client, but avoid using both at the same time. You don't want to do it because it adds the additional level of complexity to your project. It can be too complex to handle both. HTTP client to make CRUD operations executed, and then Socket IO client to make the Socket IO callbacks executed. That's what I would at least avoid, but it's up to you. If you think that at some point you need both, you can of course use both. It's not a mistake here. In our demo, we were using only Socket IO, and it worked pretty nicely. So you may ask, is this Socket IO really the IoT protocol, Internet of Things protocol? Is it good to be used in IoT? Actually, yes, but at the same time, no. Socket IO usually is having quite a heavy traffic for really small devices. Because of encryption, because of keeping the connection all the time up and running, because of energy consumption if device is running on battery, it actually could be quite heavy for the device. We are using Socket IO only when we need to control device from the office or from remote connection to the device. We are using Socket IO only on this at this point. Device itself is not reporting back to server through Socket IO. We are using MQTT for this, and MQTT is called Message Queue Transport Protocol. It was designed especially for for IoT solutions. It's the lightweight. It supports different level of delivery guarantee, and it supports different how would I say it, scenarios when you need to send last will message on device disconnect, when you need to connect multiple devices to the same broker so they can all see what is happening. There is, of course, well, I would say that Socket IO is not equal to MQTT in any sense, even if they look like they do the same job, but they don't do the same job. And the next slides would show you why. Socket IO is only guaranteed the connection and communication between client and the server side. So as a client, you can send something to the server, and then it's up to the server what to do with the message. Should it keep it in database? Should it just forget about the message? Or should it broadcast it to other clients? So this third "or" that I said should it broadcast it to other clients? This is something that MQTT does by default. So the Socket IO is something that communicates between, that helps you to communicate between your client and the server. And the MQTT broker, this is something that helps you to communicate between the clients. If one client broadcasts the message to broker, it immediately broadcasts it to other clients. And if client has a subscription on the message, it can react on it. That's actually speeds up the scenarios when you need all of your devices to be synchronized. Let's say if one device is dropped, or by device I mean, let's say that we have a motor. If one motor is shut down by some mistake, it sends the message to broker, I am shut down, there's a failure. So basically the other motors need to be stopped as well, just because of this one failure. So the whole system continue go into failure mode. Here is the picture of how communication looked like between client and server for Socket IO case and between clients in MQTT. As I said before, Socket IO provides the communication only between the client and the server. And then it's up to the server what to do with the message. Meanwhile, MQTT broker, in this case, I took HIF MQ picture, but it can be any MQTT broker. It can be a Mosquito by Eclipse or HIF MQ. When the device sends the data, the MQTT broker doesn't care what to do with this data. It just broadcasts the data to all the connected clients, laptop, mobile device in this sense. And MQTT, what is really good about MQTT is that it provides 3 levels of quality of service, which we, in simple words, call delivery guarantee. If you are using QoS 1 or QoS 2, you are pretty much good to go, because your message would be delivered even if the client is disconnected. It's up to the client implementation, the modules that you can use in Node.js to connect to MQTT broker. They are responsible for keeping the buffer, sending the messages when internet connection back to life, and resending them if the client doesn't receive acknowledgement message from the server, from the MQTT broker, that the message was delivered well. On connection breaks, the MQTT works really good. You don't have to worry about a lot of these low-level things in a network stack. You just send the message with QoS 1 or QoS 2, and then you are good to go, that you should know that your message would be delivered no matter what. And you can ask me, why don't use these, why do they have this QoS 1 and QoS 2? Why not always use the best one? It's again coming to the server hardware. You need a lot of, well, not a lot, but probably you need much more memory for QoS 1, and even for QoS 2 is even more. It requires some persistency levels, like a good file system, probably SSD, not the HDD. For QoS 0 is really simple. It tries to send, and if nothing happens, it doesn't care. It just sends. For QoS 1 and QoS 2, it expects the acknowledgement. It expects that the message would be delivered, and the report about it would be sent back to client, so client is happy. Meanwhile, Socket IO does not guarantee the message delivery. If Socket server broadcasts the message to the clients, and if client is disconnected, it wouldn't ask for the message when it connects back. That's the downside of it. So that's why when you really have to provide a solid connection between the server side, between the client side, and between different clients, Socket IO is not the best option in this sense. So it's not the best option for IoT, but it's good option for remote control. It is good option for notifications, and it's really good options for real-time messaging between the client and the server side. So Socketlo is usually hosted on the same server where you host your API. You don't have to set up the separate server for this. What you need to do is just to have the API there. Socketlo is hosted through Node.js module, and you don't need to worry about separate hosting method. Meanwhile, MQTT broker is usually a separate piece of software that you need to download, even purchase. Some of them, they're not free of charge. And you need to set up it as an additional part of your ecosystem. What we do in Stora Enso, we are using Docker, and we execute MQTT brokers as Docker in Azure. So we have public brokers, we have private brokers. All the public brokers for MQTT we're having, they are hosted as a container instance in Azure. We just downloaded the free of charge container from Eclipse and hosted it in Azure with some certificates, with some usernames and passwords, and with some authentication methods. So we a little bit covered feathers. We a little bit covered the difference between Socketlo and the MQTT. As you now learned that the MQTT is good for IoT, Socketlo is good for real-time notifications between the server and the client. We also covered the demo. Now it's time to make a little brief and speak about the deployment. How would you deploy your Feathers server? First of all, in our demo, we had the most simple case, the most simple scenario. We have only one server with only one node, which is physical instance that is running. And whoever is connected to the node, they all are connected to the same server. And if one person or one client execute the post message, all the other clients, they're getting this event back. Something was created. Let's say if customer creates a new motor, they immediately get the notification that the motor was created, and they're good to go to react on this and pop up the new chart on a screen. But this is far from the real life. In real life, we are usually having multiple nodes, and usually they are load balanced. The access to them is load balanced. If you are having a massive deployment and you expect the thousands of clients to be connected, it's never okay to just run one server. You are usually need to be running several of them, and then put a load balancer before them. So when the customer connects, the load balancer connects it to the least busy server. But what would happen if we have 5 clients and 3 servers, and all of those 5 clients, some of them connected to the same node, but some of them connected to other nodes? And if the client number 1, like on this picture, make a post requests, only the client number 2 would receive the notification, because physically they are connected to the same machine, physical machine. Even if you deploy to the cloud, to the cluster of virtual machines, it would be the same. All the clients that are connected to the different machines, because of load balancer, balance them. They wouldn't be receiving anything. So how to solve this issue when you need to scale out the deployment horizontally? You need to have so-called Feathers sync module, and the Feathers supports this synchronization through Redis cache. I will cover a little bit the Redis cache in the future slide, but Redis is the memory. Basically Redis is the memory cache. It runs in operating memory. It collects the data and then it can gives you the data by the key. So it keeps the key value pairs, key value, key value. You can write something to cache, then you can quickly read something from cache. And this cache is really, really fast. It's the most fastest thing you can even think about in the computer, because all the data is stored in the operating memory, not in the persistent memory. So in the source code, I showed you already this sync. And if not, you can take a look at this line of, so it's only one line of code. You need to have a Redis instance. And with one line of code, you write, please use this Redis instance as a sync layer. And then, even if you have 3 nodes or 5 or 6 nodes, if they all are using Redis cache, and the client number 1 make a post requests, you probably see it somewhere there or there. If it makes the post requests, all the clients are notified, because this feathers thing is pushing data to Redis and then pulling data from Redis immediately when it's available. Redis is open source in-memory data structure. It stores the, it can be used as the cache, as a database, and as the message broker. In our solution, we use it as a cache, but you can also try to use it as a message broker and broadcast the messages between your clients. We're not talking about this in this lecture. You can try it yourself. It can store strings, hash tables, lists, sets, and it supports different kind of queries to it. You can only get the data by key, or you can query it by some geospatial data. If you have some kind of points, give me everything, I mean point on map with the coordinates. You can actually make a query that it will give you all the data which is 5 miles away from your point, if of course the key or value contains those geospatial data. But this, unfortunately, this topic is not, again, is too difficult to cover within the lecture. All you need to do, all you need to remember now is to understand that the Redis is memory-based. It doesn't store anything on your hard drive. When the Redis instance is rebooted, all the data is lost. So do not rely on this, on anything else than the cache. It's just the cache. Well, actually, I already covered this slide. It tells that how the data is stored as a key value, and mostly, as I said, the Redis is used as a cache aside pattern. Before asking database, you check your cache. If data is in cache, you return it immediately to the customer. If data is not in cache, you ask it from database, write it to cache, give it back to customer. That's the most, how do I say it, the most popular way of using Redis. And actually, that's the picture. You have the cache before your database. If data is in database, if data is in cache, you get it from cache to the customer. If data is not in cache, you first read it from database, which is of course slower. That's why we need cache. If we have 1,000 requests per second, it would be much, much faster to get data once, put it into cache, and then serve the other 1,000 customers from this cache, not to make 1,000 requests for the same data to database. And I was speaking about load balancing, and actually, what is the load balancing? The load balancing is the technique when you are using only one access point, one IP address or one URL to connect multiple customers to multiple machines. We are all using load balancing in our life. If you go to Facebook, if you go to Google, you are not connected to the same IP address all the time. Physically, I mean, well, of course, it's the maybe IP address is the same because DNS is resolved through IP address, but physical machines that are running in data center, they are different. And if you need to serve hundreds, millions, or thousands user requests per second, you have to have multiple instances running of your application, and you have to put a load balancer between them. And do not mix so-called traffic manager with the load balancer. Traffic manager is something that redirects the user to the nearest point, to the nearest server based on its geographical location. Yes, they can do it. They can detect your IP address, they can map it to your country or even to the city, from which city you are, and then they can serve you the closest server which is available for you to speed up the communication. There are different rules of load balancing. It can be random rule, which is the most simple. So the load balancer picks up the server for you randomly and serves the data from this server. It can pick up the least busy server, or in most advanced cases, if it's a traffic manager, it can pick up the closest geographically the closest server to you. That's actually quite an important thing when you are really hosting something in production. You need to think about these things, and you need to really architect your solution so all the data, callbacks, post requests, get requests, they would be the same no matter to which physical machine they are, your customers are connected. And the last thing about the load balancer, I want to say that there could be a combination of those. You can have multiple load balancers which are having a random strategy, and each of them connects the customer to the set of virtual machines or to the set of servers. And you may have the one big load balancer before a set of load balancers. So when the customer comes, it first connects to the first load balancer. The first load balancer decides to which of load balancers need to redirect them next time. It could be a random strategy. Randomly, it redirects the customer to the load balancer number 3. And the load balancer number 3 decides which are a least busy server to serve. In most of the complex systems, this is the actual strategy. So they have multiple levels of load balancers from the bottom to the top, or from the top to the bottom. How do you prefer? Of course, when it comes to real life, especially when it comes to IoT, complex systems are much more difficult than just we described. You need to remember about the security, encryption. You need to remember about the authentication and especially the authorization. Who can access what? You need to remember about the operating system vulnerabilities, how to fix them, how to update. And especially hackers nowadays, they love to hack IoT devices. Usually when developers are developing IoT solutions, they don't think about security a lot. They keep the ports open, they keep the public IP addresses accessible from the device point of view to open internet. Some small devices, really small microcontrollers, they even don't have encryption because they're so tiny and small. They cannot encrypt the data because encryption is really CPU greedy operation. And always remember to put the gateway between your device and the internet. There should be one more thing called the gateway, which would filter out all the unnecessary traffic from the internet to your device if somebody tries to hack it. Never connect your device straight to internet without a gateway. And usually the router is a simple gateway. It already has the rules not to allow hackers to attack from the outside. The worst thing would happen if they just break your router, but your device in a local network would stay safe. And there is again more and more to consider. But those are the most important things to start with. I think in this lecture we covered everything what I wanted to cover. I think we speak about FeathersJS as an HTTP API implementation. We spoke about the Socketlo implementations. We watched the demo. We checked the difference between Socketlo and MQTT, in which case to use what. And we also covered the deployment. As a call of action for you today would be that you download the source code, you run it, you learn how it works, you visit the websites of Feathers, you visit the websites of Socket.io, see what they can offer you in your work or in your assignments. And on the screen now, you see my email. You can write me an email with your questions. Unfortunately, here, I don't see you face to face. But you always can contact me online, and I wouldn't be angry if you send me a message. I would be happy to answer your questions, and I would be happy to cover something in more details what you got interest about. And on this note, I say thank you for your attention, and I would say thank you for the university that allows me to make a record for you. And I really hope that you like the information and you would be finding this information valuable and useful in your work. Thank you.